Hello everyone, welcome to Young Einstein. In our last video, we talked about the sum of an arithmetic progression. In this video, we're moving on to geometric progression. We have rounded up everything on arithmetic progression. So, before I get into this topic, please make sure you subscribe, like, and leave comments on other topics you'd like to know more about. So, geometric progression. A geometric progression, as the short form is GP. The short form for geometric progression is GP. Another name for geometric progression is exponential sequence. That's another name for geometric progression, exponential sequence. Now, there's a difference between arithmetic progression and geometric progression. Arithmetic progression has what is called the common difference. That is, in between the terms, if you subtract successive terms, you get the same answer. There's a common difference in arithmetic progression. But in geometric progression, we don't have common difference. We have what's called common ratio. A geometric progression has common ratio. Now, this common ratio is if you divide successive terms, you will get the same answer. Dividing successive terms give you the same answer. Like for instance, take this series for example: 2, 4, 8, 16, 32, and so on. 2, 4, 8, 16, 32, and so on. Now, if you try 4 divided by 2, you will get 2. 8 divided by 4, you will get 2. 16 divided by 8, you will get 2. 32 divided by 16, you will still get 2. So this is an example of a common ratio. When your perfect ratio is division, so when we are dividing, we are getting the same answer. When we are dividing successive terms, we are getting the same answer. And the symbol for common ratio is R. So in this case, R is equal to 2 because the answer that we were getting was 2, 2, 2, 2, 2. So the common ratio is equal to R. Now, from what you did, you can get the formula for your common ratio. Now, remember what you did in arithmetic progression. The first term is T1, second term is T2, third term is T3, fourth term is T4, fifth term is T5, and so on. Now, we can use these terms to derive a formula for your common ratio. Like what we did, we divided the second term by the first term. We did 4 divided by 2. 4 is the second term, 2 is the first term. So we did the first term divided by the second term divided by the first term. The second term is T2. The first term is T1. So when we did 4 divided by 2, we did T2 divided by T1. When we did 4 divided by 2, we did T2 divided by T1. So the common ratio is T2 divided by T1. Or we can also use T3 divided by T2. That was when we divided 8 divided by 4. You can also use T4 divided by T3. That's the same thing we did when we did 16 divided by 8. T4 divided by T3, that's it. So, and so on. You can use T5 divided by T4, T6 divided by T5, T100 divided by T99. That's just it. So, now observe another thing. If you want to get the next term, you simply multiply by the common ratio. For instance, our first term was 2. If you want to get the next term, we multiply 2 by the common ratio. The common ratio is 2. So multiply 2 by 2, you get 4. That's the next term. If you want to get the next term after 4, you multiply 4 by 2, you get 8. If you want to get the next term after 8, you multiply 8 by 2, you get 16. If you want to get the next term after 16, multiply 16 by 2, you get 32. So we're multiplying the term by a common ratio to get the next term. So if you want to get T6, you multiply T5 by the common ratio, so I can get T6. So this, we are going to use this now to derive something. Now, like I said, first term is T1. Now you know your T1 is your first term is always represented by letter A. So T1 is equal to A. Now T2, like I've explained, you multiply T1 by your common ratio. You multiply the first term by your common ratio. T2 is equal to T1 times A. T1 times R, which will give you A times R, because T1 itself is A. That is first term is A. So A times R will give you AR. So T2 is equal to AR. T2 is AR. Now if you want to get T3, multiply T2 by R. That's T2 times R, which will give you AR times R, because T2 is AR. So T2 times R is equal to AR times R. AR times R will give you AR raised to the power of 2. So T3 is equal to AR raised to the power of 2. If you want to get T4, you do T3, that is the previous term, multiplied by R. t3 times r, which will give you ar raised to the power of 2, because we just found t3 to be 2. It will give you ar raised to the power of 2 times r, which will give you ar raised to the power of 3. So t4 is equal to ar raised to the power of 3. Once you get t5, do t4 times r, which will give you ar raised to the power of 3 times r, which will give you ar raised to the power of 4. So that's t5. T5 is ar raised to the power of 4. Now I want you to notice a pattern here. T5 is ar raised to the power of 4. T5 is ar raised to the power of 4. T4, we got ar raised to the power of 3. T3, we got ar raised to the power of 2. T2, we got ar, which you can also call it ar raised to the power of 1. Now T1, we got a, which can also be written as ar raised to the power of 0. From the laws of indices, r raised to the power of 0 is 1. R raised to the power of 0 is 1. So ar raised to the power of 0 means a times 1, which is just a. That's why T1 is equal to a. So you can see that like we had the fifth term now, the power of r reduced by 1 from 5 to 4. That is T5 equal to ar raised to the power of 4. For the fourth term, the power of r will reduce from 4 to 3. Now ar raised to the power of 3. For the second term, the power of r reduced from 2 to 1. That's ar. For the first term, the power of r, from T1 now, the power of r reduced from 1 to 0. That's ar raised to the power of 0. And I've explained that will give you a. So in Excel, what I'm saying is that whatever the term is, it reduces by 1, and what you get will be the power of r. So in general, Tn is equal to ar raised to the power of n minus 1. That's you're reducing your number of terms by 1. Tn means the nth term, reducing the number of terms by 1. So what this simply means that you'll get, if you ask to find s in T10, if you ask to find T10, you simply write ar raised to the power of 9 because you're using the 10 by 1. If you're asked to find T21, you simply write ar raised to the power of 20 because you're using 21 by 1. Now, let's look at an example. A straightforward example, short and easy. Example 1. What is the ninth term of the series? 60, 30, 15, 7.5, and so on. What is the ninth term of the series? 60, 30, 15, 7.5, and so on. So, this is a straightforward series. But one problem about this series is that we don't know if the series is an AP or a GP. So you have to first know what series it is before you use your formula. You know, AP has its own formula. GP, we just got the GP formula. So if you cannot identify which series it is, you will not be able to solve it because you have to know the formula you will use first. So if you look, it is clear that this series is not an AP because there is no common difference. 30 minus 60 will give you minus 30. 15 minus 30 will give you minus 15. We first got minus 30, now we're getting minus 15. So the difference is not common. That is minus the difference is not common. So there is no common difference. So since there is no common difference, this series is not an AP. So let's check if it's a GP. Apart from arithmetic progression and geometric progression, there are still other series, countless numbers of series. It's a series that combine arithmetic progression and geometric progression together. So you have to first check. It's not that if you say it's not arithmetic, then automatically it's geometric. No, there are still other series that it could be. That even though it's not arithmetic, there's still other series that it could be that are not still geometric. There's still other series. But for now, we're focusing on arithmetic and geometric. Or geometric time around. So let's check if it's geometric. Is there a common ratio? If you try your common ratio formula, that is r is equal to T2 divided by T1, or T3 divided by T2, or T4 divided by T3. If you start with T2 divided by T1, T2 is second term, T1 is first term, and second term is 30. First term is 60. So T2 divided by T1 means 30 divided by 60. 30 divided by 60 is 0.5 according to your calculator. Now, you can also write this in fraction as half, but I will not use fractions this time around because it will be easier to work with decimals. Why? Because a number in the question is in decimal. So since a number in the question is already in decimal, our calculation will be easier working with for that decimals. You can also work with fraction, no problem. You will not get a wrong answer. But just for ease of calculation, it's better to work with decimal since a number in the question is a decimal. If a number in the question was a fraction, the same way it will be easier to work with fractions. So let's work with decimal. So 30 divided by 60 is 0.5. Now, if you get to the other formula, that is T3 divided by T2. T3 is the third term, T2 is the second term. The third term is 15, the second term is 30. So when you have T3 divided by T2, you're talking about the third term divided by the second term, which is 15 divided by 30. 15 divided by 30 will still give you 0.5. If you use the third formula, T4 divided by T5, T4 in this case is 7.5, T5 is 15. 7.5 divided by 15, you still get 0.5. So the ratio is common in all three places. So you have a common ratio here, and your common ratio, that is R, is equal to 0.5. R is equal to 0.5. And if you look at the question, the first term in the series is 60, so A is equal to 60. Now, we are asked to find the ninth term, that is T9. According to what I've explained previously, T9 will be AR raised to the power of 8. You're reducing the 9 by 1 to get 8. So T9 is equal to AR raised to the power of 8. And you know your A to be 60, you know your R to be 0.5. So T9 is equal to 60 open bracket 0.5 close bracket raised to the power of 8. Now I'm intentionally putting this bracket to indicate and to stress the fact that the 8 raised to the power of 8 is not affecting A, only affecting R. The raised to the power of 8 is not affecting A, it's only affecting R. So A is not raised to the power of 8, only R is raised to the power of 8. In the same case, 60 is not raised to the power of 8, since 60 is A. It's only 0.5 that is raised to the power of 8, since 0.5 is the R. So now I'm putting inside the bracket. So now you find 0.5 raised to the power of 8 separately, which will give you 0.0039 approximately. So T9 is equal to 60 open bracket 0.0039 close bracket. That's what you have now. Now this 60 open bracket 0.0039 means that you should multiply 60 by 0.0039, which will give you 0.351. So T9 is equal to 0.351, and that's your ninth term of the series. It's easy. It's that easy. So let's get into a more difficult and hectic example, but still, if you follow it, it's easy. Now, example 2. A GP containing 4 terms has a common ratio of 2/3. Express the GP if the last term is 4. A GP containing 4 terms has a common ratio of 2/3. Express the GP if the last term is 4. So, from what we have in this question, they said that the GP contains 4 terms. That's from the first sentence of the question. As the number of terms in this series is 4. It is not an infinite series. An infinite series is a series that doesn't have an end, like all what we have been doing, both from our AP up to now. The series I've been working with are infinite series. That is, after a few set of numbers, I'll put dash dash dash. That is to continue. It continues without an end. But now this series, they say it's only 4 terms, so it's finite. It's finite. So the number of terms in this series is 4. N is equal to 4. And from the last statement of the question, they said express the GP if the last term is 4. So this last term, which is the 4th term, since there are only 4 terms in the series, the last term is the 4th term. They said this 4th term is 4. So 4th term, you can represent 4th term as T4, remember. So T4 is equal to 4. And also, they also gave us the common ratio. So R is equal to 2/3. The common ratio is 2/3. So express the GP. That statement where they said express the GP means that you should find all the terms in the GP. Each term in the GP. This is not going to be difficult since the GP has few number of terms in it. That is, you only has 4 terms in it, so you can easily get the 4 terms. And out of these 4 terms, we already know one. We already know that T4, that is the 4th term is 4. So we're only asked to find 3 more terms. And when we get the 3 more terms, you write them out. That's how to express the GP. When you get all the terms, you write them out. So that will be the GP. So we are going to start with the information we have. We're going to start with the information we have. That is T4 is equal to 4. That's what we have. T4 equal to 4. And your formula for T4 is AR raised to the power of 3. That is, you're reducing the 4 by 1 to get 3. The formula for T4 is AR raised to the power of 3. And you don't know your A, which is your first term, but you know your R, which is 2 over 3. And you know your T4 itself to be 6, to be 4 rather. So T4 is equal to AR raised to the power of 3. So we know T4, we know R, we don't know A. So in this equation, what we can look for is A. And looking for A means we're finding the first term. A is the first term. So we are still on the question which says express the GP. Expressing the GP means finding the first term, second term, third term, and fourth term. So in this process, we are going to find the first term, which will now leave us with the second term and third term left. But we already know the first term, remember. So T4 is equal to AR raised to the power of 3. And T4 itself is 4. So we have 4 is equal to A, open bracket, 2 over 3 raised to the power of 3. T4 became 4. A, we don't know A, is still A. R is 2 over 3 and it's raised to the power of 3. So that's why I have 4 is equal to A, open bracket, 2 over 3, close bracket, raised to the power of 3. Now, according to the laws of indices, your power law, you can go check out my first video on this channel, the power law. If you have something like this 2 open bracket, 2 over 3, close bracket, raised to the power of 3, you can distribute the power to both the numerator and denominator. What I mean is that you now have 4 is equal to A, open bracket, 2 raised to the power of 3 over 3 raised to the power of 3. The power of 3 that was outside the bracket is now shared between both numbers inside the bracket. So that is what you have now. 4 is equal to A, open bracket, 2 raised to the power of 3 over 3 raised to the power of 3, close bracket. Now 2 raised to the power of 3 means 2 times 2 times 2, which will give you 8. 3 raised to the power of 3 means 3 times 3 times 3, which will give you 27. So we now have 4 is equal to A, open bracket, 8 over 27. Now you can open the bracket. You have 4 is equal to 8A over 27. Then cross multiply. You have 8A is equal to 4 times 27. 4 times 27 give 108. So 8A is equal to 108. Now you divide both sides of the equation by 8 so you can find your A. So when you divide both sides by A, using your calculator, 108 divided by 8 will give you 13.5. Now you can leave your answer at 30.5. There is no problem there. You are correct. But to ease further calculation, because we're not done with the question yet, we still have to find T2 and T3. So to ease calculation on those parts, it is not advisable to leave your answer in decimal. Now, since a number in the question was a fraction, that's the common ratio in the question in the fraction. It was 2 over 3. So let's continue working with fractions. So instead of using calculator to do 108 divided by 8, it's best to reduce it to the lowest term. So 4 in 8 is 2, 4 in 108 is 27. So you have 27 over 2. So your A is 27 over 2. And remember, A is the first term. So T1 is equal to 27 over 2. And 27 over 2 in mixed number, you can write it as 13 whole number, 1 over 2. So I've gotten T1, and we know T4. What is left is T2 and T3. So let's get T2 and T3. So T2, the formula for T2 is AR. You're using the 2 by 1 to give you 1. So that's AR is to the power of 1 actually, but the power of 1 would not be visible. It will just be AR. So T2 is equal to AR. Remember, A is, we just found A to be 27 over 2. So T2 is equal to 27 over 2 times 2 over 3. 27 over 2 times 2 over 3, which will give you 3, 2 in 2, we cancel 2 out, 3 in 3, 1, 3, 27 is 9. So what you just have left is 9. So your second term, which is T2, is 9. I've gotten T2. Now T3. T3 The formula for 2 3 will be AR raised to the power of 2 because you're reducing the 3 by 1 to get 2. So we know A is 27 over 2 times R is 2 over 3. So we have 27 over 2 times open bracket 2 over 3 close bracket raised to the power of 2. Like what we just did, you separate the powers to both terms. So it will be 27 over 2 times 2 raised to the power of 2 over 3 raised to the power of 2, which will give you 27 over 2 times 2 raised to the power of 2 is 4. That is times 4 over 9 because 3 raised to the power of 3 is 9. So 2 in 2 is 1, 2 in 4 is 2, 9 in 9 is 1, 9 in 27 is 3. So what you just have is 3 times 2, which will give you 6. So T3 is equal to 6. Then we only know our fourth term, that's the last term, T4 is equal to 4. Know that already. So I've gotten first term, second term, third term, and fourth term. So T1, T2, T3, T4 is equal to 13 number 1 over 2. That's the first term. 9, that's the second term. 6, the third term, and 4, the last term. So that is how you express the GP. So I've gotten the answer for this question.